Hello, so for today's experiment we're going to be analyzing hard water. Now in theory you could actually collect water samples from different places if you have permission to do that. I just create a fake sample of hard water using calcium chloride. But the idea here is that we're analyzing the water sample to see the concentration of calcium ions and to see whether the location that the water is coming from, whether a water softener would be useful. So what I will typically do is give each lab group a different concentration of calcium ions. And they don't know what the concentration is in advance, but I'll use different amounts of calcium chloride to make those calcium water samples. Then that becomes our limiting reactant, and they want to make sure that they're using an excess of carbonate ions, so an excess reactant. I typically will use sodium carbonate just to make sure that the sodium chloride is completely soluble and it will be a spectator ion. And so I make sure that they figure out how much they should use to make sure that it's an excess compared to like the highest possible calcium ion concentration. Then when they react these two together, they're forming a calcium carbonate precipitate. So this is really their gravimetric analysis experiment for the year, where they are reacting to soluble substances and creating an insoluble product. And then they will filter, wash, and dry the precipitate out to then work backwards to find the amount of calcium ions that were present in the original water sample. Okay, so for the experiment part of this, I have 50 milliliters of our unknown calcium ion solution. It's going to simulate our hard water solution, but it doesn't matter exactly how much calcium chloride that you put in there, because it's just simulating a sample that you got from wherever you're taking your water sample, whatever city or location around the county. So I'm going to add that calcium chloride into the beaker. This is going to be our limiting reactant. And then I'm going to add in excess of our sodium carbonate solution. It is saturated. There is a tiny bit of solid sodium carbonate at the bottom. I'm going to try to decant in order so that that solid doesn't get transferred over to the beaker. But as long as you have an excess of the solution, it should be fine. And so you can immediately see the calcium carbonate precipitate forming. And we're going to go ahead and filter this stuff. So we have our filter paper that we weighed. I'm going to put that down into the Buchner funnel, and I'm going to get it nice and wet so that it creates a good seal. And then I'm going to hook it up to the side arm of the aspirator here. Now, if you don't have vacuum filtration like this, you can just use gravity filtration. It is not a problem. Making sure there's a really good seal. And then I will turn the sink on so it will create a negative pressure and create suction in our sidearm flask. And then I will start to filter.
I don't like the anti-Semite. We're on Black Lives Matter.
I'm also going to give the beaker a good rinse with some deionized water just to make sure I've got all of the precipitate out.
You know what? I'm going to sacrifice my skin. Let's go. I saw a little tornado outside my house. It was like one of those little dust slash heat.
Okay, now that it's pretty much completely filtered, I'm going to give it one final rinse just to make sure if there's any leftover sodium ions or chloride ions, they've all passed through the filter paper, and I'm leaving only the calcium carbonate up on top. So you always want to make sure you're doing that with a precipitation reaction. You filter, wash, and then we're going to take this out and dry it. So I want to take the filter paper out of our sidearm flask. I'm sorry, out of the Buchner funnel. I like to use the end of a scupula for this. And transfer this to a paper towel. Like that. And then I will stick it in the drying oven and dry it until it reaches a constant mass. We want to make sure it reaches a constant mass so that way we know that all of the water has evaporated. Okay, so here are the overall results for this experiment. We used 50 milliliters of our hard water sample, and the mass of our dry filter paper was 0.40, and then after drying to a constant mass in the drying oven, we had a mass of 1.19 grams with the filter paper and the precipitate. Subtract out the mass of the filter paper, and you get the mass of your precipitate by itself. Then we can change grams to moles using the molar mass of calcium carbonate. It's 100.08 grams per mole. And so we have 0.00789 moles of calcium carbonate, which is equal to the moles of calcium ions because it's a 1-to-1 ratio there. And then finally we can convert that back into molarity. So we can use the 0.00789 moles of calcium over, change that to liters, 0.050 liters, and we get the molarity was 0.158 molar. Now you could put this in different units if you choose. Sometimes they'll do like grams per liter or grams per 100 milliliters, and then you can compare it to like some given like cutoff where a person would need to use a water softener. You could also have students rank. This is what I do. I'll have the students rank them in order from the least concentrated calcium ions to the most concentrated calcium ions, so they can see like which one is most likely to need a water softener versus least, and have them put them in order. But this is just a really nice way to practice gravimetric analysis procedures, and then relate that to sort of a real life scenario where water softeners are definitely something that some people will need depending on where you live due to the hard water problems. It's also a good time to talk about like boiler scale and how the scale can build up in pipes, why you would need to descale things like your coffee maker where the hard water might be running through, things like soap scum, a lot of interesting conversations that can relate the chemistry to the real world. A couple of sources of error that you could talk about: if you didn't dry out the precipitate all of the way, then this mass would be too high because there'd be extra water in it. So when you subtract out the filter paper, your mass of the calcium carbonate would be too high, your moles would be too high, and therefore your molarity would be too high. Another source of error might be when you were getting the filter paper out of the Buchner funnel, maybe some of the calcium carbonate got onto the scupula or was left behind in the filter. That would make your mass too low, which would decrease your moles and therefore decrease your molarity. But yeah, really good experiment. There are lots of other possible precipitation reactions you could do, but this one opens up for a lot of good discussions. And calcium carbonate shows up in a lot of different experiments, so it's good to give kids the exposure to that compound.